So this time we're exploring networks, which is the third layer of the OSI model. It's responsible for basically sending packets through the network and getting them to their destination. Response to requests and all that sort of other stuff. It's also responsible for message forwarding and that sort of stuff. But before we dive a little more into what this layer actually does, we also need to actually look at network topology and a few other things as well. So moving on to topology. Topology is basically the shape of the network. What is connected to what? Now, the simplest possible network you can have set up is basically point-to-point, or two things connected to one another, or back-to-back, whichever. Next is daisy chain, which is one computer connects to the next, and so on to the third, the fourth, and fifth, and so on. You can have a common bus that is shared. An extension of the bus is actually the ring network, where the bus goes round all the computers. Jumping back a step, there's also the star network, which has a central point or hub. I want to say that word, but it's not the right in this case because hubs are different hardware, and we'll get to that in a second. But a central point where everything comes back to it. Next up is the mesh. Now there's a partial mesh topology where each computer is connected to one or more computers. And then there's the full mesh, which every computer is connected to every other computer. And then finally we get various hybrid techniques. And this is a little bit more complication because it's basically you can get things like a star of a star. So you can have one star that links to multiple star networks, much like most school setups. We'll have a central server, and then the priority system's connected straight off that, and then individual classrooms may be wired up as an individual star point off that bigger network. There's also, what else? There's a ring of stars. So there's a central ring that everything's connected to, and each point on that ring is a star off to something else. And network topology gets more and more complicated from that point onwards, and at various stages then you're looking at almost the internet really, or metropolitan area networks or wide area networks. But back to the actual individual devices in this sort of case. So there's a short list of devices that are provided here. Gateways and firewalls, they share a lot of things together, but basically NICs, or network interface cards, are basically hardware that connects a computer to a network. Then you get things like repeaters and hubs. Now, a repeater I mentioned earlier with fibre optic going under the sea, because it's only good for about 1 kilometre, there's a repeater that picks up that signal and then relays it on, henceforth extending the reach of that network to the various hundreds of kilometres that stretch across the ocean floor. You also get hubs, which take a signal and just bounce it to all the connections that are on that hub. Bridges, which connect two seemingly disparate networks together. Switches that are designed to not quite route traffic, but decide where the traffic goes in that small little thing. Routers take that to the next level and are actually connecting between, they're routing traffic between different networks, which is an important distinction. Even though they both seem to occupy the same conceptual space, they're really aimed at doing different things at different layers of the OSI model. Then you have modems, which is actually modulator demodulator, and that's from the old acoustic coupler days, where it would take a digital signal and turn it into a series of tones to transmit across the old telephone networks. These days, because of digital subscriber lines and other similar technology, we have no need for it, and a modem is almost like a carryover from those early days. But basically a modem is designed to carry signal across a network that's not designed for digital traffic. Gateway, which is basically a node in the computer network that processes local traffic to other networks, including the internet. And firewall, which is a device designed for maintaining network security between the external to the network and the internals of that network. So an outer wall for a castle, say. Okay, so moving on to the more detail on the gateway side of things. So a gateway also speaks multiple languages, so it can communicate between the local network and also any special protocols out there on the wider internet. It may be hooked up to other systems that allow it to, say, bounce a signal from one part of the city out to the university, say, or a similar sort of setup where it's covering a huge distance with a different piece of technology, maybe a satellite or maybe just a radio link or that sort of stuff. So it's designed to provide gateways to other areas, and that's the whole idea behind what it is and what it's called. Now, the actual network gateway itself can operate at any level of the OSI model, and this sort of, I suppose, leads to a little bit of confusion. But in essence, I've already covered what it's meant to be doing. So, next up, we have firewalls, which almost become a special function within a gateway. It's designed to prevent unauthorized access and to limit the communication between outside the network and inside the network, and to really sort of provide that scale of protection. Now, things can still go on with the network, and there are ways of bypassing firewalls, but really it's designed for that level of protection. So, breaking down the firewall into a little bit of a history lesson, the first generation of firewalls were really just packet filters. This operates at OSI level 3, and it's basically deciding what packets would be dropped or gotten rid of. Now, it could do this silently, or it could actually notify the sender. But basically, if that packet broke the rule, it would just get rid of it. The second generation was what they call a stateful filter. So it would also monitor that connection to develop an idea of what that external IP address was accessing, what it was looking for, and that sort of stuff, and what sort of connection was being maintained there. So it's a little more complexity, but it would still suffer from the denial of service attack, such as the ping of death. Then there's the third generation, which is really operating on layer 7 of the OSI model, which is up the top there. But anyhow, its really goal here is to interrogate every packet of data coming through, trying to understand what it's about, what it's trying to do, and whether it's accessing FTP, DNS, HTTP, or any other service that may be operating on the server or within that network, and trying to identify ways that people are trying to either break into the system or cause trouble and that sort of stuff. Now, moving back towards a more general idea of the services that are offered on a gateway, we also have things like network address translation, which actually also doubles for on the firewall side of things. But basically, the whole idea of that is that outside the network, you request the certain IP address of where this server is, or whatever particular port. You'll be tunneled through to that one particular service that you need, and you will not be able to access anything else. And the entire internal workings of that network are then concealed from you because you can't access anything else except for that one thing you're allowed to. You also get automatic content filtering or blocking of particular IP addresses, and this is great for automated ad blocking. And the Pi-hole, which is a project that is possible, is really looking at setting one of those up so that it automatically filters out particular IP addresses to stop ads. Then, of course, you've got the caching of websites. So it's actually possible to take an entire chunk of the internet and cache it locally. So that you could take Wikipedia and set it up on, say, a Raspberry Pi, for example, as a local copy of that thing, and update it periodically as changes occur. Finally, there's VPN tunneling. I've included it here. Probably should actually include it elsewhere, but either way, it's basically controlling the links for a LAN with it, helping create, in this case, a wide area network. The goal here is to make it the internet invisible, so that when you connect to another remote computer, say from where we are here to, say, somewhere in the US, and it's all part of the same company or business or whatever, that you just go, I want to talk to that computer over there, and it automatically connects. You don't care about anything that happens in between. Your connection is secured, and the IT professionals can make sure that that connection is secure, and then you can just go about your business without dealing with any of the techie stuff. Anyhow, this then brings us on to another part of networking, which is the Internet Protocol Addressing System. Now, IP version 4 had basically a 32-bit number, and you can see that up on the screen there, and it provided, I think it's a bit over 4 billion possible addresses. Thanks to the development of the mobile phone, and each phone basically needing its own unique IP address to connect to the internet, they've run out pretty quickly. So we're moving to IP version 6, but I'll get to that in time. But this IP version 4 did also allow for private subnets, and I'll go into the various classes of the networks that exist. So the first, when this was originally set up, the first generation of address classes were assigned to the big companies of the day. Now, this was Hewlett-Packard, the Digital Electronics Corporation, IBM, and a whole bunch of other ones, some of them who no longer exist. Microsoft didn't get one of these because it didn't exist at the time. It got a B class address, and then C classes for all the other minor services. And also because it was set up in the US, it's very American-centric in terms of access to the IP addresses. Now, moving towards, you've got multicast reserved for future use. So up here we've got the multicast bracket and the reserved for future uses. And I can't really go into more detail on that, but there's also one address, IP address, which is for limited broadcast down the bottom there. And each of those have particular uses and that sort of stuff. And if you want to find out more, I'd suggest you go research yourself. But within those IP ranges, there are basically certain reserved blocks of IP address that are for certain private uses, like internal networks. So most large-scale businesses use the 10.0.0.0/8, which is this top Class A block for referencing and setting up their own internal networks. Class B and C are also available. It depends on what you want to do. Most will just go Class A because it's basically the biggest bracket of addresses. And I'll get to the other special case in just a moment, which is 127.0.0.1. But moving on to IP version 6. IP version 6 is basically the new updated version of the Internet protocols, an addressing system. It's got a range of hexadecimal numbers to create 128-bit worth of address codes, which is far more than we'll hopefully need for the foreseeable future. And when you want to terminate your IP address, because any trailing zeros can be ignored, you just have two sets of colons and that's it. And you just basically, you can see the example up there and that sort of covers it. And finally, to end with a bit of an internet joke meme thingy, there is no place like home, as said in the classic Wizard of Oz movie.